Hello everyone, welcome to VLSI Gold Chips. In this session, we will see about VLSI roadmap, job opportunities in VLSI and all. Hey future VLSI engineers, so welcome back to the channel. So if you are dreaming about a career in semiconductor industry, you are in the right place. Today I am going to share the roadmap to help you break into the VLSI industry. So whether you may be a beginner or someone who has already started their journey, so this video will guide step by step on what to study, how to prepare, and the projects you need to build to land up into the dream job. So let's get started. So let's see why this VLSI roadmap is required. So before we dive into the roadmap, let me tell you why this is so important. So the semiconductor industry is not just growing globally, it's booming right here in India. So with the rise of AI, 5G, EVs, and IoT, so demand for the semiconductors has increased. And guess for what? So India is stepping into the big time to become a global hub for semiconductor manufacturing and designs. So the Indian government has launched ambitious initiatives like the Semiconductor Mission, the PLI scheme, the CHIPS Startup Scheme to attract investments in the sector. The companies like Intel, TSMC, Micron are setting up plants and design centers in India. So this means that thousands of new jobs have been created. And the industry is looking for skilled engineers like you to fill these roles. So this VLSI roadmap is divided into 4 parts. So as an electronics engineering student, so which domain to choose, whether to choose software, embedded or VLSI, so that you'll get an idea from this VLSI roadmap. And domains in VLSI that we'll be discussing in this video. The foundational topics you must master no matter which domain you choose, and the domain specific skills and the projects to make you stand out. So let's see why this is the best time to join VLSI. So India's semiconductors boom because the government is focusing on making India a global semiconductor hub. So the industry is set to grow exponentially in the next 5 to 10 years. A high demand, less competition, unlike other software jobs, where thousands of candidates compete for the same role, whereas in case of VLSI, there is a less competition, but high demand. If you have the right skills, you are the golden. Cutting edge work, you'll be working on technologies that power the future, from AI chips to 5G processors and automobile vehicles. So global opportunities are also there. The skills you learn in VLSI are in demand worldwide, whether you want to work in India, US, Europe or Taiwan, the world is your playground. So let's see the domain for electronics student, software, embedded, VLSI. Whether to choose software, embedded or VLSI. So let's talk about the job market. In software and embedded system, there are hundreds of programming languages like Python, Java, C, C++, JavaScript, and all. The list goes on. You need to constantly learn new languages and frameworks to stay relevant. On the other hand, in VLSI, you only need to master a few key skills like Verilog, System Verilog, maybe Python or Perl for scripting. That's it. Okay. You don't have to keep chasing the new big languages or the framework like LLM and all. So there are very good packages in VLSI. Let's see. In software and embedded roles, the starting salary for freshers is around 4 lakhs per annum on an average. But in case of VLSI, the package is very good. It is almost double, 8 lakhs per annum for freshers. Okay, if you have experience, okay, maybe 5 to 10 years, then you can easily earn 20 to 30 lakhs per annum or even more than that, okay, depending on the expertise. Okay, that much demand is there and the skill set is required for that in VLSI. So let's see why is VLSI the best choice for electronics engineers. So your background fits perfectly because electronic engineers are very much required. You have a strong foundation in digital electronics, microprocessors, microcontrollers, and the computer architectures. So these are the core skills which are required in VLSI. So less competition, unlike the software jobs, where thousands of candidates would compete for the same role. VLSI has less competition but high demand. Cutting edge work. In VLSI, you get to work on latest technologies like AI chips, 5G processors, autonomous vehicle systems, etc. You are not just writing the code, you are designing the hardware that powers the future. So there are global opportunities as well. Semiconductor industry is a global. Companies like Intel, Nvidia, Qualcomm, TSMC are always looking forward for skilled VLSI engineers. That means you can work in countries like US, Germany, and Taiwan if you want to. So you have opportunities in global as well. So what about the software or embedded jobs? So now you might be thinking, what about software or embedded jobs? Aren't they good? Sure, they are. Okay. They are saturated actually. So there are too many candidates and not enough high paying jobs. So they may have to write the code again and again, debug and test. Okay, it is a repetitive job. Okay, you may be feeling bored if you join a software or embedded job role. In VLSI, the work is more challenging and rewarding. You are designing the hardware that runs the software. You are solving complex problems that have real impact on the world. So now let's see about the major domains in VLSI. So VLSI design engineer is a job role. Okay, there's a core for semiconductor industry. So as a design engineer, you'll be creating the digital circuits that power chips using hardware description languages like Verilog or VHDL. So for this job role, the skills which are required are strong understanding of digital electronics, proficiency in VHDL or Verilog, You need to have knowledge of computer architecture and microprocessor design, familiarity with EDA tools like Cadence or Synopsys. So these are the resources which are required. Okay, digital design by Maurice Mono, Verilog HDL by Paul Nitka, computer organization and design by Patterson and Hennessy. So these are the resources which you already learned in engineering. The next job role is verification engineer. Okay, so you can think of this role as the quality checker of the semiconductor world. Your job is to ensure that the design works as intended and is free of bugs. You will use languages like System Verilog and methodologies like UVM to create test benches and simulate different scenarios. The skill sets which are required for this are proficiency in System Verilog and UVM, strong debugging and problem solving skills, knowledge of protocols like AXI, AMBA, and PCIe, familiarity with EDA tools for simulation. The resources which are required for this are System Verilog for verification by Chris Pure, a practical guide to adopting the UVM, which is a grade for UVM concepts. The next job role is physical design engineer. So once the design is verified, it's a time to turn it into a physical chip. So that's a role of physical design engineers. So they take the RTL and convert into layout or the GDS2 file. So deciding where each transistor, interconnect and gate will be placed on the silicon. The skill sets which are required for this are deep understanding of timing, power and area optimization, knowledge of EDA tools like Cadence, Innovus or Synopsys ICC, familiarity with STA, that is static timing analysis, basics of semiconductor physics. So the resources which are required for this are Physical Design Essentials by Golchin, STA for Nanometer Design by Bhaskar, and VLSI Physical Design Automation by Sadiq and Yusuf. Okay, so this is the job role, skill set and the resources which are required for PD engineers. So if you want to become analog or mixed signal design engineers, okay, then you can choose this particular job role. So you'll be working on the circuits that process real world signals like audio, video and sensor data, okay, which includes amplifiers, filters, ADCs and DACs. Okay. The skill sets which are required are strong understanding of analog electronics and signal processing, knowledge of Virtuoso custom compiler, and familiarity with the ADC, DACs, amplifiers, and the filters. Okay, so the resources which are required for this is design of analog CMOS integrated circuits by Razavi, then CMOS circuit design, layout and simulation by Baker, and then analog integrated circuit design by John and Martin. So these are the job role, skill set and the resources. So next job role is FPGA design engineer. Okay, FPGA means it is field programmable gate array. so which can be programmed to perform the specific task. So if you want to become FPGA design engineers, so you'll be designing and implementing the digital circuits on FPGAs using tools like Vivado or Intel Quartus. So for this, you should be proficient in Verilog or VHDL. So you should have knowledge of FPGA architectures and timing constraints and familiarity with high-speed designs and protocols like PCIe or Ethernet. So these are the resources. So FPGA prototyping by Verilog examples by Wong P. Chu. Advanced FPGA design by Steve Kitts for advanced FPGA concepts and Xilinx Vivado user guide. Okay, this is about FPGA design engineer role. Next is DFT engineer. Okay, that is design for test. So you'll ensure that chip can be tested for defects after manufacturing by inserting scan chains and the built-in self-test structures. The skill sets which are required for this are knowledge of scan insertion, ATPG and fault models, familiarity with the EDA tools like Synopsys, DFT compilers, Mentor Tessent, and the resources which are required for this have been listed here. Fine. That is essentials of electronic testing for digital memory and mixed signal VLSI circuits by Michael Bushnell and Vishwani. DFT training material by Synopsys. So these are the resources for DFT engineer. The next job role is CAD engineer. So we'll be developing and maintaining the EDA tools used by design and verification engineers. So the skill sets which are required for this are proficiency in programming languages like Python, Perl, or TCL, knowledge of EDA tool development and automation. Resources for CAD engineers are Python for engineers. It's a free online tutorials and PDFs. TCL or TK for EDA tools available on Mentor Graphics website. Okay, if you want to become CAD engineer, so these are the skill sets and the resources. Next job role is application engineer. So we'll be acting as a bridge between the company and the customers, providing technical support and training. The skill sets which are required for this are strong communication and problem solving skills, technical expertise in VLSI tools and design flows, and then the resources which are required for this are technical communication by John M. Lennon, EDA tool users guide by which are available in websites of Cadence, Synopsys, and Mentor Graphics. This is about the job role of application engineer. So if you want to become R&D engineer, that is research and development engineer, so this is where the future of semiconductor technology is shaped. So the R&D engineer will work on cutting edge technologies like AI chips, quantum computing, or next generation transistors. So the strong foundation in semiconductor physics and advanced electronics, knowledge of emerging technologies like AI, IoT, or 5G would be required as the skill set. So the resources or Semiconductor Device Fundamentals by Robert F. Parrott for Semiconductor Physics, and research papers from IEEE Explorer for latest trends in VLSI. So this is about the job role of the R&D engineer. Okay, so these are all the job role, skill set, and the resources which are available in the market. Next, how to choose your domain. Okay, which domain you want to choose? Let's see. So if you are loving coding and designing circuits, go to RTL design or verification. So if you are passionate about turning designs into physical chips, choose PD, physical design domain. So if you enjoy working with real world signals, then explore analog or mixed signal design. So if you are into testing and quality assurance, DFT is a great option. If you love innovation and research, go for R&D. So these are all the key to choose a domain that aligns with your interest and the strengths. So here are some of the foundational topics to master. Digital electronics. So this is your bread and butter. Okay. So the subject is very much required for VLSI engineers. You can start with MISO Academy's digital electronic course and practice as much as you can. Verilog, learn how to write a synthesizable code and map Verilog constructs to hardware. I would recommend the Samir Parnitkar. Okay, Verilog HDL textbook. CMOS basics. Okay, so you need to understand about NMOS, PMOS, and CMOS inverter characteristics for this digital IC designed by Rabe. Computer architecture. Learn how processor works, pipelining, cache, and memory hierarchy. For static timing analysis, master setup, hold, clock skew, and other timing concepts. C programming would be required. Coding is essential in VLSI. You can start with C and then move on to other languages like Python. EDF flow basics. Understand the end-to-end VLSI flow from RTL to GDS2. Low power design techniques. Learn about dynamic power, static power, and leakage power, where you will be trying to optimize the circuits. Scripting, Python or Perl will help you automate tasks and analyze data. Aptitude and puzzles. Companies test your problem solving skills, so practice puzzles and aptitude questions daily. So these are all the foundation topics to master to clear the interviews and get into the VLSI job. That's it. Okay, this is about the VLSI roadmap. So you have great opportunity in VLSI domain. You can choose the appropriate domains and you can get into VLSI job. Thank you.